Good evening, everybody. We'll begin today's session. So this is the first question. If the black lines represent cutting lines and dotted pink lines are folding lines, which of the following options correctly represents the opened up surfaces of the solid shown? In this kind of question, the first thing to do is to first count the surfaces. So in option A, when I counted, there were 12 surfaces. In option B, there were 13 surfaces. Okay. In option C, there were again 13 surfaces, and D also had 13 surfaces. When I counted the square, this is just square surfaces, okay? Because that is crucial here and it is easier. So that's why I just counted the 12 square surfaces. And in this figure, the number of square surfaces are 13. So option A is clearly wrong, not possible. Then once you do this, it is actually crucial for you to check if there are any overlaps happening in B, C, and D, because although the square surfaces are the same, if they are overlapping, they won't be completing the figure. That's why. If you observe option D very carefully, what I mean is if they are overlapping, ye wala jo part hai aapka, this part comes here, this part will come here. Likewise, ye wala jo part hai comes here and then upar, which means that there is a clear overlap which is happening between this part and this part, this square and this square. So D is not possible. B and C are all correct. There is no issue of any overlap in B and C. If you want, you can check it out. So B and C would be the correct one. Here you're given a diagram which shows distribution of population in an apartment building as per the profession of its residents. One or more option is correct in this case, and that's why we'll go from option to option to check with the pie diagram. The first option, doctors and businessmen combined is less than half of the total residents. Doctors is blue and businessmen is green. So this is and this one. If you look at the angle that blue sector and green sector has, it is less than 90 degree. If it is less than 90 degree, which means that the combined is less than half. That is obvious. If this angle is less than 90 degree. So A is correct. Now, if A is correct, automatically D will be wrong, because D mein diya hai doctors and businessmen combined is more than half of the total residents. So D is wrong, obviously, by that rule. About 1/3 of the population is engineers. If you look at this sector angle, it is actually 1/3 of the total. 1/3 matlab 120 degree ke aaspaas hai ye wala angle. So that's why option B galat sahi hai. In case of option C, engineers and designers combined is about 60% of the residents. Engineers and designers. Engineers are here, designers are here, which is purple and red. Engineers and designers is about 60%. If doctors and businessmen combined are less than half of the residents, obviously ये आपका ज्यादा ही है, ये 60% के around ही होगा. It is because of course it's more than 50, and this itself constitutes to be 1/3 of it, and plus this is also more than 90 degree. So this has to be roughly around 60. So that's why C is correct. So A, B, and C all are correct. The figure shows illustrations of metal rods which have internal and external screw threads. This is an internal screw thread. This is an external screw thread. The shaded portion in the figure shows the cross-section view. What is the maximum length possible by connecting the rods? Threads cannot be connected partially. You have to, when you connect the thread, ये वाला external thread है, वो यहाँ तक नहीं आ सकता है, उसको through and through जाना पड़ेगा. Basically, that's what it means. You have to find a maximum length that is possible. Now, if you look at these two threads, which are of course bigger in size, but then they both have internal screw heads, which means connection possible nahi hai without this part, without the external thread part. So that's why first we'll use, so this is 1, 2, 3, 4, 5, and 6. First we'll use 3 to 6 to connect. So the diagram, I'm just drawing a rough diagram here. So this is 3, this is 4, this is 5, this is 6. So far I have used 1, 2, 3, 4. This is 200, 200, 200, 200. ये total dimension 200 है यहाँ से यहाँ तक. That's why. Then I can still use one metal rod with internal connector. So I'll use one of these, say number 2. So I will use that here. This dimension is 220. So 200 is happening 4 times, so 200. So the total dimension that we have achieved is 200 into 4 plus 220, which is equal to 800 plus 220. 1020 is the correct answer. That's why. Okay. Here you're given a surface development. Figure onto the left shows an unfolded pattern of a dice. If 4 such identical dice are stacked one on top of other, like you're seeing here, 2, 3, and 4. What is the sum of the numbers appearing on the faces which are parallel to the ground? Sum of the numbers appearing on the faces which are parallel to the ground. Here, I am not concerned whether some number is happening on top or bottom. I just have to find a series of numbers which are located along this horizontal surface. Along this horizontal surface at all, for all the dices. And then even here. So I know 5 is there, which is given. मैं नीचे से चालू करूं. फर्स्ट डाइस में 1 और 2 दिया है, 1 और 2 दिया है. 1 और 2 के एक साइड 4 आएगा और एक साइड 3 आएगा. सो इफ आई अज्यूम बॉटम टू बी 4, तो यहाँ पे इसका जो नीचे वाला, जो इसका जो 1 डाइस का टॉप है विल बी 3. एंड देन इसका जो सेकेंड डाइस है उसका बेस है, दैट वी हैव टू फाइंड. 6 and 3. 6 और 3 साथ में है. 6 और 3 मतलब ये वाला एज और ये वाला एज साथ में ज्वाइन होता है, तब एक साइड आपका 5 आएगा और एक साइड 1 आएगा. सो वन साइड इज 5 एंड ऑफ कोर्स अनदर साइड इज 1. One second. Yeah, I write it here only. Next one, dice 3. उसके बेस में क्या आएगा? 5 and 4. 5 and 4. 5 and 4 are happening here. ऊपर 6 आएगा, नीचे 2 आएगा. 6 and then 2. इसका 5 एक साइड है, एक साइड 2 है और एक साइड 4 है. 5, 4 and 2 they are together. One top is 5, the bottom will be 1. So यहाँ पे 1 आएगा. When all I have to do is add all of them together. So 5 plus 1 plus 2 plus 6 plus 1 plus 5 plus 3 plus 4. When I add all of them together, the answer that will come is 27. The attached image shows a corridor floor which is covered with square tiles of the same size. How many tiles are covered in the green patch which is provided below? Now here, if you observe very carefully, there are certain groove lines which are actually visible to you. If you observe very carefully the diagram that is given. For your A's, I'm just going to draw the pattern, so it becomes easier. This is the pattern of the groove lines. Somewhere roughly like this. So when you look at the grid that we are getting is 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Instead of counting, it's much easier. So it's a 6 by 6 grid, which is 36. Within this 6 by 6 grid, one tile, second tile, and third tile are not there, are not part of the green patch. 36 minus 3, which will be equal to 33. Okay. Just 1 second. So when I add this up, it comes to, so I subtract this up, so it comes to 33, which are the number of tiles that are there in the green patch. Okay. We'll move to the next one. What you're provided here is, you're provided here 20 points. They are arranged like this in a plane. What is the highest number of squares that can be drawn using any of the 4 points as corners? We have to find the maximum number of squares that can be drawn. The first attempts are just going to draw single squares which are possible. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So like this, we get 9 squares. After this, we are going to draw the squares which combines bigger squares like this. So 9 plus 4. After this, I'm going to draw another layer here only, which combines squares like these. So again, plus 4. After this, you're again going to go for larger squares, but they are at a weird angle, like these. This is one typology. So this is second type. Sorry, not that. This is second typology. Besides this, there are still 2 more which are left. Yeah, we use a different color. The same thing happens. So again, plus 8. Sorry, plus 4. So when you add this thing up, it comes to 21. Okay. Move to the next one. Here, you're given a graphic pattern. What you have to find is the area of the black surface that the image has. All the curves are same radii and use the value of pi to be 22/7. That is what is provided. Now, if you observe this pattern very carefully, if I find the area of this much part, if I find the area of this much part, if I multiply it by 4 times, I will be able to find the area of the black part. If I find the area of the black part only in this much part, I'm writing it as part A. In part A, if I find the area of the black part, I will be able to, I just have to multiply it by 4 because in the second quadrant, in all these 3 quadrants, is the same pattern which is happening. So now I'll just decode the geometry that part A has. In order to decode the geometry, I'm just going to extend the lines of the square that is there. This is the square that is getting formed. Within this, there are certain parts which are repeated, like 1 and 1 is getting repeated. This is the second part and this is the third part. All I have to do is I have to find the area of all. Why area of 3 also? Because although it's white, is because without the area of 3, I won't be able to find the area of 1, which is an odd shape. That's why. So first we'll find the area of the square, which is of 7/7. Area of square of 7 centimeters is 7 into 7, which is 49. Therefore, area of part 2, which is this one, will be half of 49 area of the square, which is equal to 24.5. So this is one part. I've already found the area of part 2. Now I'm interested in finding the area of part 1 because part 1 consists of the black part, and that is 2 of such black parts are happening. In order to find the area of part 1, I will first find the area of part 3 and subtract it from the total part. Okay. So area of part 3, which is a sector of a circle with angle 45 degree, will be pi r squared theta upon 360, which is pi is 22/7 into r square is 7 square. Radius is 7 because ye wala jo vertical hai aapka, that is 7. That's why radius is 7. Multiply by theta value is 45 because diagonal bisects the 90 degree. So 45 upon 360. 7, 7 will go away. This will be there. So it will come to 77/4. When you resolve this, it will somewhere come to about 19.25. Sorry, 19.25. Now I've got the area of part 3. I'm interested in finding the area of part 1. Okay, so area of part 1 will be area of part 2, which is the diagonal of the square. I mean, half of the one triangle or half of the square, which is 24.5, minus sector ka area, which is 3, which is 19.25. This will come to 5.25. I found all the parts that are required to find area of part A. So area of black in part A will be equal to the part 2, which is 24.5 plus 2 of 1 is happening 2 times. So 2 into 5.25. When you solve this, this will come to about 35. Therefore, area of black part will be equal to 35 into 4 because it is happening 4 times, which is equal to 140. Okay. Here you're given a ceramic tile which is of dimension 20/20. How many distinct patterns can you create by using 2 such ceramic tiles in a rectangular patch of 40/20 centimeters on the wall, which is given here? If you observe very carefully, this is all the possible options which you can get in the dimension of 40/20 or ye 20/20 jab ho to. This is a 40/20. This is also 40/20. This is also 40/20. These are all the unique patterns that you can get, which is 16 patterns. Without, if you want to solve this without actually decoding the patterns, you have to find is this can be rotated 4 times to find different shapes. This is one. This is another shape if this is black part. This is a third rotation. And this is a fourth rotation. So it can be rotated 1, 2, and 3, 4, 3 and 4 times. So if one tile can be rotated 4 times and there are two such possibilities, so 4 multiply and एक का 4 times rotation, दूसरे का 4 times rotation, so 4 into 4. So that's where that's how also we get 16 possibilities. Okay. Move to the next one. Here you are provided a graphic at most means maximum how many triangles can appear by adding can appear by adding 2 straight lines to the figure. Now I'm interested in getting the maximum triangle, so the shape that I will insert inside is also that of a triangle and not anything else, because if I draw a straight line like this, all I will be doing is I'll be getting few triangles. I won't be getting more triangles like this. 1, 2, 3, 4, ये वाला बड़ा वाला 4, 5 and 6. इसमें 6 मिलेगा. But if I insert a triangle shape here itself, there's a possibility that I will get even more triangles. Like if I insert it like this, the number of triangles in this possibilities would be 1, 2, 3, 4. This is 4. One, 2, and 3. Then 1, 2, and then 3. So this will give me 10 triangles. Okay, that's why, which is the maximum number of triangles that I get by getting these lines. Here you are provided certain patterns, motifs. How many distinct motifs can appear? How many distinct motifs appear in the figure on the right is what your distinct motifs appear in the figure on the right. How many distinct motifs appear in the figure on the right, which is asked. Flips and rotation are to be counted separately. जैसे P का rotated version is Q. You rotated 180 degree and you get Q. So this is a distinct pattern and this is another distinct pattern. Now this is just an example. We don't have to count P and Q. We are just interested in finding the distinct motifs that are there in R. I'm just going to mark the motifs that are distinct here. Three, 4, 5, 6, 7, and 8. So in this diagram, you get 8 such distinct motifs. Okay. If you want, I'll just quickly write down the numbers. This is like 1. This is like 4. This is like 5. This is like 1. This is again like 5. This is 6. This is 4. This is like 2. This is 4. And this is 5. This is provided. This is 1, 2, 3, 4, 5, 6, 7, and 8. So this is all I've done a numbering where 1 means this refers to this one. They are the same. That's all I've done. So likewise, we get 8 such motifs. Okay. We'll end today's session with this. Thank you so much.